exam paper, right? So again, good afternoon to everybody. Just as we get the live part of it going, maybe it would be best to sort of look back at the objective of the session, right? Let's kind of go back to that first slide. And at least where we reach, though, we'll kind of take it back from there from Sunday to today, right? So the objective of the session, I think we are in 1.2. Or are we still in 1.1? Let me see. Explain the hazards inherent in the oil and gas arising from the extraction, storage, and processing of raw materials and products. I believe we're there, because we have actually covered parts of investigating incidents and how we can learn accidents, right? So I suppose where we are at is still in 1.2. We could trace it right here. You'll see 1.2 is where the definitions started from. We have covered flashpoint, vapor density, vapor pressure, flammability. We are on toxicity now, skin irritant, carcinogenic properties. I think we did upper flammability limit and lower flammability limit already, right? So that is to give us some kind of direction and as to where we are at right now, right? So toxicity is the degree to which a substance is able to damage an exposed organism. Toxicity can refer to the effect on a whole organism, such as an animal, bacterium, or plant, as well as the effect on a substructure of the organism, such as cell or an organ, the liver, for example, right? So, like certain chemicals, then, right? And there are different versions of chemicals, some of which, of course, would be um, accidental, like an accidental exposure, but some of them is actually on purpose, right? So example like alcohol, affects the liver, right? So there are many types of toxic entities. We have chemical, biological, physical. Skin irritant. Irritation is a state of inflammation or painful reaction to allergy or cell lining damage. A stimulant or agent which induces the state of irritation is called an irritant. Irritants can be chemical agents, but also mechanical, for example, fiberglass, thermal heat, and radioactive stimuli. For example, ultraviolet light or ionizing radiation can also be irritants. Carcinogens, a substance that is capable of altering the genetic material of an organism, leading to abnormal growth of tissue cells that can become cancerous with resulting tumors. Carcinogens can be attributed to radiation, for example, gamma rays and alpha particles. Other common examples of carcinogens are inhaled asbestos, many gases, of course, ammonia and stuff, right? Certain dioxins and tobacco smoke. That's the Global Harmonized System. The GHS stands for Global Harmonized System for carcinogens. I would suggest to learn this one. This is kind of popular, right? Um, like what you get wrong, what you get incorrect is if you say a carcinogen causes cancer, that is be wrong, right? So a proper definition is a carcinogen is capable of altering the genetic material of an organism, right? Leading to abnormal growth of tissue cells that can become cancerous and result in tumors. So that's 2 marks. You should commit this one to memory, fairly common for exam, right? A bunch of references here if you want to check them up. Some of these you can probably link on them, and if you want to do any further reading where that is concerned anyway. All right. Properties and hazards of gases. I'll slow down because some of these, when I say slow down, I slow down on some of them. Some of them are popular, some of them not too popular. But they all have come though, right? They all have come, which makes it harder for you as a student because you kind of have to learn them, right? But I could probably slow down on the common ones, right? And kind of go faster on the ones that are not too common, right? So we have let's go back to this one. We have hydrogen. So hydrogen is a colorless, odorless, tasteless, flammable, and non-toxic gas. It is the lightest of all gases. Hazards can include hydrogen is flammable over a wide range of concentration. The lower flammability limit is 4%, the higher flammability limit is 75%. The ignition energy for hydrogen is very low. What it means, it could explode, it could, hydrogen is more explosive than fire causing then, right? So the ignition energy for hydrogen is very low. This means it can ignite even with very low energy sparks. Liquid hydrogen is extremely cold and can cause frostbite and cold burns. Can be an asphyxiant in its pure oxygen-free form. A hydrogen leak can rapidly become a large flammable vapor cloud. Right? So if I was learning something, I would have probably learned the top. Hydrogen is a colorless, odorless, tasteless, flammable, and non-toxic gas. It is the lightest of all gases. I think that may be able to give you the mark. I don't think you need to know, you could probably say it have a flammability range, but you mightn't want to remember the flammability range, right? I don't think you get an extra mark for that. I think it's easy to describe it on top. Most participants say it like that: colorless, odorless, tasteless, flammable, non-toxic gas, right? Methane is a naturally occurring combustible gas that is colorless and odorless. Methane is the primary component of natural gas. 97% by volume of natural gas is methane. Methane comes from a number of different sources. Underground deposits of natural gas are the primary source of methane. Methane is also trapped in pockets near coal deposits. Methane can also be stored in a liquid form, which is only flammable under high atmospheric pressure, right? The thing you're looking at there is the chemical structure for methane. This is how you represent it. I think this is called a chemical formula. The one in the middle is actually carbon. This is C, and you have four H's, one, two, three, four. That's the molecular structure of methane. If you want to remember, it is up to you. Those of us who may have done high school chemistry, you may already know it, CH4. But you still have to kind of learn the definition part of it that says methane is a naturally occurring combustible gas that is colorless and odorless, right? Um, I think that may be sufficient. These definitions come for 2 marks, right? If we finish maybe around 20 past 7, we could look and see a passage. But these kind of thing come for 2 marks, 2 marks, right? Definitions are 2 mark questions anyway, right? So methane is extremely flammable in the presence of oxygen. The lower flammability limit is 5%. The higher flammability limit is 15%. You would remember from last week Sunday, it's really the mixture of, the vapor and the air. So that's why you see here the presence of oxygen. Inhaling methane can be life-threatening because it causes asphyxiation. Asphyxiation is another word for saying it's difficult to breathe, right? It causes asphyxiation by displacing the surrounding oxygen. Methane reacts violently with oxidizers, halogens, and halogen-containing compounds. And of course, we could probably print this as a big slide. Sources of methane have been found naturally occurring in the colder parts of, I guess, the world. We have the Arctic here. You have methane deposits, and that may have been, there because of fossil fuel, right? Methane is a fossil fuel. Anything with carbon and hydrogen are really fossil fuels anyway. We have solid methane hydrates, ice forms in band, and lenses close to the surface, right? So methane has been found in cooler countries. It tends to settle a bit. I wouldn't say it's found too much in the Caribbean because we have brilliant sunshine, and then we have sort of, like a good system of, like the breeze then, right? So like if you check the UK, it's a little bit more damp, right? A little bit more boggy. One of the word like they use is bog, B-O-G. Like a bog is what you see in here. It's cool, it's grass, but it's ice, right? Like we don't have those sort of conditions then for methane to be trapped. But we do have natural gas, of course, in Trinidad, right? Of course, Guyana as well. But I do think the temperature then and the sort of the wind temperature, wind speed and stuff does a bit of ventilation so that the gases don't settle. In the UK, if you wonder what I'm talking about, is the gases settle. Like if you have a basement or in the subway or in a parking lot with lots of cars, like how we have, uh, like parkades and stuff, but the gases could settle there, the methane, because it's naturally in the soil and in places like England, right? Some people have suggested, other sources of the methane, like this is just science are telling me, right? I just telling. So some people say fossil fuel is the source of it, but then some people say like there have been past explosions then, right? Whether or not like you believe it, if it's naturally caused or man-made, there have been past disasters then, right? And they say some of the fallout from those things would have radiation and have things like methane gas throughout certain parts or certain continents then because of what they would have gone through in the past, right? Luckily, though, the Caribbean have not been sort of traced to any sort of past explosions. Past here meaning past, like beyond time, modern day time and then, right? But they have traced certain things back then to ancient times then, right? Or pre-recorded times that have had explosions. And that's why certain parts of the world they say have certain things that are naturally occurring. And of course, we of course in the Caribbean have not been linked to anything like that. So like methane is not really too much occurring here because of the temperature and even some of those past folklores that may have linked explosions to certain parts of the world. If you don't know what I'm talking about, I'll tell you after the class, but not on the record, right? I show you a look at these things all the time. There are many theories or the conspiracy theories and stuff like that out there, right? All right, next one we have liquid petroleum gas, LPG. I've seen this one too. I've seen LPG, I've seen LNG to define them, right? Again, we could check some participants and see we can't do two at the same time. So we could run through this first and then look at the participant afterwards, right? So produce some petroleum. LPG is a mixture of gases, propane and butane, which belong to the same family as methane, right? For those who know that, that's called, like organic or organics. Methane is actually the first one. Sorry, then you have methane, you have ethane, right? You have is it methane, ethane, butane, propane, right? So all of them is the same family anyway, right? Its use include fuel for cooking, propane gas, of course, heating and vehicles. And as a refrigerant, it is colorless and odorless and has a odorizing agent added for leak detection purposes. Hazards can include it is a flammable, non-flammable in the liquid state, mixture of hydrocarbon gases. The lower flammability limit is 2%, and the higher flammability limit is 10% of propane and butane. Right? Remember, propane is the gas you use in your kitchen. And as some of us know, if there was a leak, you normally get a smell. But if you look at the definition, they say propane is actually colorless and odorless. So then how do you get a smell? Anyone knows how do you get a smell? If the definition says it's odorless, but then if your gas tank is God forbid leaking in the kitchen or it's coming to the end of it, you sort of pick up a smell. So how does that happen? But the definition said it's odorless. Anyone
They add
knows?
it. They add it for detection.
Right. So they add a gas for detection so that because methane, propane, but methane could have a smell based on where you're getting it from. Right? You could get methane from animal droppings and stuff like that. But propane, of course, is odorless. So they add a odorizer to it, right? For the propane tanks in your kitchen in the event of a leak, so that you will know now that the gas is leaking. But the propane itself doesn't have a smell. What you smell is the odorizer that has been added to it, right? Very good there, Devon. LPG is approximately twice as heavy as air when in gas form and will tend to sink to the lowest possible level and may accumulate in cellars, pits, and drains until it's find an ignition source. And of course, I did mention this in the type of countries and more those kind of cool areas that we could have condensation taking place, right? LPG is stored under pressure. On release, it reverts to its gaseous state. The gas becomes about 250 times its stored liquid volume, thereby creating a flammable vapor cloud. At very high concentrations, when mixed with air, the vapor is an anesthetic and subsequently an asphyxiant by diluting the available oxygen. Again, asphyxiation means difficulty to breathe because it's replacing some of the oxygen, right? LNG, again, just learn like one line for it in terms of a definition, is a liquefied natural gas. It's it originates from underground natural oil and gas reservoirs often discovered through drilling and exploration operations. LNG is principally used for transporting natural gas to markets where it is regasified and distributed as pipeline natural gas. LNG hazard, the gas is a liquid because it is stored at very low temperatures, minus 162 degrees Celsius at around atmospheric pressure. Because of its temperature, minus 162 degrees Celsius, right? It is very cold and can cause cold burns. At ambient temperature, the liquid rapidly expands, which is normal temperature now, to 600 times the volume of its liquid form, forming an odorless and highly flammable gas. And of course, the two figures are there as well for the lower flammability limit and the upper flammability limit. LNG hazards may result in a pool fire. Such fires are not possible to extinguish if there is a large spillage. The fire will have to be left to burn out until all of the LNG, sorry, is consumed by the fire. Right, very famous one, hydrogen sulfide. So found in crude oil and gas, hydrogen sulfide is considered a broad spectrum poison, meaning it can poison several different systems in the body, although the nervous system and respiratory systems are most affected. Besides being highly toxic, H2S, supposed to be a small two, but then that's how it's printed here, is a flammable gas. It also causes irritation to the eye, skin, and the mucous membranes. Hazards, of course, of hydrogen sulfide, right? Highly toxic, extremely low concentrations at concentrations of 800 parts per million, which is, of course, very small. 50% of the people will die within 5 minutes of exposure. At 1,000 parts per million will cause instant collapse and loss of breathing, even in one single breath, right? I just had a pop up on the screen. I'm just waiting for it to go. So, toxic and fire explosion risk if it finds an ignition source. It has an extremely pungent odor, the smell of rotten eggs, but rapidly destroys the sense of smell due to its corrosiveness. This means that potential victims may be unaware of the danger. It can be smelled by humans at concentration as low as 0.00047%. Don't learn everything, of course. I know you're not going to do that because all of us working anyway. But just kind of pick like one good line, for it in terms of describing it then, right? Highly toxic at extremely low temperatures. Um, that sort of thing to just give it like 2 marks now, right? When you're looking at your definitions anyway. All right. Potential hazards of gases, oxygen. Well, I shouldn't read this one. I could just explain. I think we all know the air we breathe is 21% oxygen. Of course, if anything sort of gets in the way, it decreases the oxygen supply. Anything less than 21% is oxygen deficiency, and anything above 21% is oxygen enrichment, right? So you can have a read of this one for yourself, right? And I sort of mention that one here, right? So a small increase in oxygen levels in the air to 21% oxygen enrichment can create a dangerous situation. It can become easier to start a fire, which will then burn hotter and more fiercely than in normal air. It may be almost impossible to put out a fire. A leaking valve or hose in a poorly ventilated room or confined space can quickly increase the oxygen concentration to a dangerous level. For example, the HMS Glasgow incident in 1976, right? We could pull up that a bit. I don't think they really do much of case studies at this level. Those of us who did the degree level would sort of remember some of the HMS adventures anyway, right? But of course, you could check it out and see, right? Those who did like a unit E and stuff would have had case studies, and they don't really test case studies at this level anyway, right? Anti-foaming. If you want, I can explain some of these instead of reading it. It's an anti-foaming agent, but the thing is, you may have to remember some of it then. So that's what I'm trying to read, right? But an anti-foaming agent is one that does exactly what it says, right? So anti-foaming agents may be oil, powder, water, or silicone base. The first line, a deformer or an anti-foaming agent is a chemical additive that reduces and hinders the formation of foam in the industrial process liquid. An increased feature is a low viscosity and a facility to spread rapidly on foamy surfaces. So hazards associated with anti-foaming agents generally concern skin or eye irritation. An anti-foaming agent being tested on foam, see how the foam disperses with the anti-foaming agent. I've never seen that one though, right? Anti-wetting agents. Water is often detrimental to materials when their surface becomes penetrated by moisture. Think about the offshore industry. Metal surfaces can corrode and wood degrades, right? So anti-wetting agents, for example, Teflon, places a waterproof barrier between the surface of the material and the water. For example, seawater and rain, right? So if you have any sort of material that, well, any, pipes and whatever, it would be good to treat them before you put them into such conditions then, right? So such coatings can be said to be hydrophobic or water repellent. Anti-wetting agents effectively offer good corrosion protection. So once you have a good maintenance program, which most companies don't have, well, I mean, most local companies, of course, the bigger companies have, you know, good maintenance programs, right? And like we have seen in the region, and like equipment may have been past inspection, but it could have just been paperwork and not really corrosion treatment and stuff like that, right? Of course, you all know what I'm talking about, offshore rigs and
Yeah.
whatever had with that collapse, right? But they would have had inspection reports pass. But, corrosion and stuff have not been dealt with and wear and tear have not been dealt with, right? So here you have like they added on like an anti-wetting agent here, and you sort of notice like the water droplets will kind of fade away or roll off that material surface. Sort of like what we would say in the Caribbean here, like a dashing leaf, right? I mean, that's a plant, of course, right? So the anti-wetting agent offers a barrier then between the metal surface and water sources. Think a lot here about the offshore industry. So this would be very good for them. And they do that. Most of the equipment would have been treated, and primed with an anti-wetting agent before use in the like in the water courses then anyway, right? Doesn't have to be offshore. Some of it could actually be onshore as well. Right. Properties and hazards of associated products and control measures. We have microbiocides. I've never seen this one, but all of these are on your syllabus, right? So microbiocides are used in the gas and oil industry to control the growth of bacteria and prevent the formation of harmful byproducts of their growth, such as the hydrogen sulfide. A biocide is a chemical substance or microorganism. Despite the name biocide, or despite the name, a biocide does not actually have to kill. It may instead deter, render harmless, prevent the action of, or otherwise exert a controlling effect on any harmful organism by chemical or biological means. Biocides can be added to protect materials, typically liquids, against biological infestation and growth. In refineries, for example, that uses include the treatment of cooling water to remove the prevent spores, fungi, Legionella bacteria, and to prevent bacterial slime or film, FILM, which significantly reduces heat transfer in cooling systems such as heat exchangers, right? So you could just take the first line. There are not too much of these here, right? I mean, I've never really seen biocide. And the thing about Nibosh,
Yes,
remember, they kind of go down.
they tend to
Mhm.
they
Go
tend
ahead.
to use it often offshore. Yes. They
Yeah.
tend to use it often offshore. They will inject it. So when it reaches downstream, you will get that buildup of the well,
Film.
especially for the hydrogen sulfide.
Yeah.
They tend
Yeah.
to put scales to prevent the scales from building up. they will
Yeah,
inject the biocide on the facility and send it downstream.
right. Right. And I mean those things, if you don't know if these things are bad or not, but these things are bad, right? Legionella bacteria is bad. If you don't know, it causes a disease called legionellosis, and that is like COVID. You get fever, cough, cold, and it affects your lungs, right? So it can lead to pneumonia. So like there's a need to get rid of those things then, right? And the biocides would actually offer protection against those as well. Corrosion prevention. So these are additives which are used to delay or prevent the formation of corrosion within vessels, pipelines, and structures. Refrigerants. A refrigerant is a substance used to provide cooling either as the working substance of a refrigerator or by direct absorption of heat. Common refrigerants include ammonia, sulfur dioxide, and propane. Head risk includes flammability, toxicity, and cold burns. At high levels, they can cause central nervous system depression and cardiac arrest. Vapors displace air can cause asphyxiation in confined spaces. Um, Hazardous properties of water. So water exists in three states. We know that solid, liquid, and gases, right? Uses include cooling, lubrication, for example, drilling mud. We actually come into that in a bit. Fire, water source. And water, of course, can be converted to steam, and there are many types of steam. Well, two main types, which is, saturated steam and superheated steam. That's another lesson, but at least you could use the water to get it to the gas form and the form of steam then, and then you could use that for other energy purposes, right? So power turbines to generate electrical power, to drive pumps, compressors, fans, and other equipment. Steam, which is in essence water, right? Can be a heating source for control rooms, tank coils, and trace heating for certain processes, right? So like the saturated steam here, um, can't remember too much here either in terms of past papers, but a nice concept, right? So saturated steam is an excellent heat source, particularly at temperatures of 100 degrees Celsius, so 212 Fahrenheit, and higher, and has the following advantages: improve product quality and productivity. Temperature can be quickly and precisely established because it's only 100 they're going up to. And like they use steam, I mean, they wouldn't really use too much of this steam because the other one is better. Superheated steam is better than saturated steam, right? But I suppose you could use saturated steam as well based on what they want to do with it in the process, right? Temperature can be quickly and precisely established. Smaller required heat transfer for the surface area, enabling reduce initial equipment outlay. And that's just saying that you don't need a lot of energy there to get to this sort of steam. This is like boiling water in your kitchen. So it depends on what you're using it for. I mean, this saturated steam is called wet steam, so it has some water in it. So it depends on what you're using it for, right? If it's just for cooling purposes of transferring heat, I suppose it's good in that sense, right? Rapid even heating through hidden heat transfer or latent heat transfer. It's safe, it's clean, and it's a low cost because it's just sort of boiling water anyway, right? Saturated steam has three main disadvantage in steam engines or whatever they're using it for, cleaning steam lines or whatever, cleaning, equipment. It contains small droplets of water which have to be periodically drained from the cylinders. So remember, saturated steam is called wet steam. It inevitably condenses to some extent in the steam line and cylinders outside the boiler, causing a disproportionate loss of steam volume as it does so, and it also wets the surface of the material because it condenses now, so you'll get water. So it could actually lead to corrosion, right? It places a heavy demand on the boiler because a large amount of water has to be evaporated per unit volume of steam. This one is actually better. Superheated steam is the same steam. Just to let you know, when I said this one is the same steam. You can probably put your boiling water is the same water you boil that will give you the first steam you'll get is called saturated steam. right? If you check under your pot covers and stuff, you would see water droplets, but you see steam, right? But if you keep on heating by adding another heat source, right? So if you have a blowtorch, which you probably don't have, but if you have blowtorch and you keep heating like a vessel, like a kettle, right? It's not just keeping the fire going, but it's increase the heat source. What will happen? The steam will actually get to superheated steam, and that's anything above 100 degrees Celsius, right? Um, at that temperature, the steam is actually invisible, so you actually wouldn't see it. If you're seeing steam, that is saturated steam. Like when you're boiling water, that's saturated steam. But if you were to increase the heat source, not increase your stove or the time, but to add in some blowtorches, increase the temperature, you will see the water vapor will disappear and you won't see the steam anymore. But that's actually the good steam that could actually do a lot of cleaning, like rusted parts and whatever have you. It's very good for that. It's also flammable as well, right? That steam could actually catch a fire. The same thing that came from water. Stranger, the gas that came from water, when it gets to the superheated steam, you cannot see it. And if you have like paper, if you take like paper and you put it there where you have saturated steam, the paper will actually catch a fire, right? So it is steam which is formed at the temperature that exceeds that of saturated steam at the same pressure or the same temperature and pressure. So the steam above saturated steam, above the temperature of saturated steam, and saturated steam is that of boiling water, which is 100 degrees Celsius, is called superheated steam. So there's a study more use here for cleaning purposes because this steam doesn't have water in it. So things like computer parts, chips and stuff like that, computer, you know, uh, hardware, right? So surface technologies, cleaning technologies, catalysts, surface drying technologies, curing technologies, soil steam and energy systems, and nanotechnologies, right? Those kind of thing then, and they could probably get in Silicon Valley would have the computer parts and stuff then would be clean with superheated steam, right? It doesn't, you know, affect the material. It's still a steam, um, silicon and those parts and stuff could take that level of heat, but it doesn't wet it at the same time like saturated steam. So superheated steam is very good, for cleaning, surfaces and, that sort of technology aspect of it then, right? The bits and the chips and whatever have you that would make up components for your phones and your computers, etc. Right? So steam hazards and associated control. We have thermal expansion, formation of vacuum, water in the steam lines that create like a sound, especially if the water is changing direction in a line, or the steam is, which they do, right? If you have seen any steam lines, I'm just trying to draw that for you. If you've seen any steam line in the oil and gas industry, they sort of go up like that and they come back down. This is like a line on the road or wherever you are at, right? I mean, if it's on land, right? Steam lines, you can tell a steam line because they are silver or they have a silver material wrapped around them, right? But they do this sort of design with them, right? So these points that they could actually hear like the liquid, sort of making contact with the pipes itself. You could actually hear that knocking sound then, and that's called a water hammer, right? So water in steam lines. Water hammer is the unexpected release and associated shock wave of high pressure steam condensate. If you do have a blowout and stuff, can cause death, severe injury, or extensive property damage, scalding, serious physical injury, etc. Right? Let me move on from that. Vacuum formation during drying operations, sorry, during drilling operations. So what that one is that they sometimes use this steam to clean vessels or tanks. And if it is put a tank, I guess, um, have a tank door there, right? So like if they use this steam, right, what's gonna happen because it could be hot, and of course it's steam we're talking about, especially superheated steam, it may cause the metal of the tank to expand a bit, right? And what they say is that when they draw out that steam, this is a tank door, and this would be like a manhole on top here, right? If they draw out the steam suddenly, right, it could cause, because the tank was expanded, it could cause them to now come in. And remember, this tank wall is actually, well, some of it is welded on, but some of them have bolts on them. They're actually bolted on and welded on. So you see like a seam on the tank, right? A tank is not one sheet of metal per se. You see like a seam, like where they welded there. And if you look at them closely, you see like another seam. Like when you iron your clothes, there's a seam on your clothes, right? So if that is what is being done on a regular basis, and nothing is wrong with using steam, but if they were to withdraw it suddenly, what they say it causes a vacuum, and the vacuum is able to cause the tank then to collapse on itself. So I'll just draw it like that, right? The tank could actually come in and collapse on itself, right? So the tank will sort of buckle inside then, right? That's what is called vacuum formation. Right. So that's just a hazard of using steam other than the burns and the, well, saturated steam, that is, right? Um, we have hydrostatic tests, weighting, or hydrostatic testing and weight. A hydrostatic test is a way in which pressure vessels such as pipelines, plumbing, gas cylinders, boilers, and fuel tanks can be tested for strengths and leaks. The test involves filling the vessel or pipe system with a liquid, usually water, which may be dyed to aid in visual leak detection and pressurization of the vessel to the specified test pressure. So some of us know this, they use like water in testing tanks, hydrostatic testing. So if a tank has to hold oil, as this is the oil and gas course, but I suppose if it had to hold fuel or even grain, well, grain is not really the oil and gas course, right? But if it had to hold oil or fuel, well, they would fill it with water first then. And that's what the hydrostatic test is. They'd fill it with water, keep it at that temperature, pressure, see if it could withstand the volume of the liquid placed in it then, right? Especially if it's a new tank or maybe a tank that would have been modified or welded on or whatever have you welded back into service then, right? So they'll fill it with water and increase the pressure within the tank and see if the tank could withhold that. And that process, of course, is called hydrostatic test. And some vessels do fail. When it's hydro test, we would have known of one at Trinma, right? They would have fill a tank there, and the tank did fail. But of course, luckily, it wasn't oil in the tank; it was just water that was being hydro tested there, right? For the tank for strength or whatever have you, right? So hopefully the whole tank doesn't collapse, and that's not what they want. But I've seen it, and you all have seen it too. Some of us who from that side would have seen it. Tanks do fail, right? Some of them due to manufacturer's defect, which would have been linked to some sort of welding defect, right? Or structural defect when the tank was put together anyway. All right. So hydrostatic testing, a good way to sort of test it with water. And if there is a rupture, it will be bad, but it's just water as opposed to oil or fuel, right? All right. Water hazards and associated controls. So cooling tower areas reject, and heat rejection devices that reject waste heat to the atmosphere through the cooling of a water steam to a lower temperature. That's a cooling tower. Typical hazards can include the Legionella bacteria and water vapor fog. The Legionella bacteria, as you mentioned, is linked to a disease called Legionellosis. It's a collective term for diseases caused by the Legionella bacteria, including the most serious Legionnaire's disease, which I told you what makes it bad is the link to pneumonia, right? Outbreak of the illness occur from exposure to Legionella growing in purpose-built systems where water is maintained at a temperature high enough to encourage the growth. Cooling towers, evaporative condensers, hot and cold water systems are all where you can find the Legionella bacteria. Certain conditions would have to be right though for the Legionella bacteria to grow. They say the temperature of the water in the cooling tower, right, must be within 20 to 55 degrees Celsius, which is suitable for the Legionella bacteria to grow. It is possible for breathable water droplets to be created and dispersed, example via aerosols created by a cooling tower or water outlets. Water is stored, wherever water is stored and or is recirculated. Um, Mercaptans are a group of sulfur-containing organic chemical substances. They smell like rotten cabbage. If mercaptans are in the air, even at low concentrations, they are very noticeable. Pulp mills are the chief source of mercaptans. They are found in production process of petroleum products. Mercaptans, they are also used as an odorizing agent in the same propane tank, the natural gas, the propane tank we spoke about. The human body produces them naturally during the digestion of beer, garlic, and some other foods. The vapors, if inhaled, can cause headaches, nausea, dizziness, drowsiness, and a loss of consciousness. They may also be irritating to the eyes, respiratory system, and the skin. The Milan incident in 2004, an exhausted mercaptan canister used by a natural gas distributor was being returned to the supplier for refilling. Just give me a minute to admit somebody, right? The canister sprung a leak while in transit at a road delivery company in Sesto San Giovanni, a town just north of Milan, Italy. Gas was carried by the wind across the eastern half of the city of Milan, causing residents as far as 12 kilometers from the canister to make thousands of calls that overwhelm the emergency services of 4 hours and risk hiding actual gas leaks because remember, mercaptans is just like a odorizer anyway, right? Looking at the time, maybe we should here we stop right here. We stop at this question here, right? So let's go to sludge. Sludge is let's put this first one, right? So drilling mud, my mistake, drilling mud. Using the oil and gas drilling process and referred to as drilling mud, the main function of drilling mud includes providing hydrostatic pressure to prevent formation fluids from entering into the well bore. Keeping the drill bit cool is also use of the drilling mud and cleaning during drilling. Carrying out drill cuttings. When they carry out drill cuttings, they use the mud as a coolant. Suspending the drill cuttings while drilling is paused, and when the drilling assembly is brought in and out of the hole. Types of drilling fluid include water-based, gaseous base, and synthetic, but they just use mud. I mean, they're different types, right? Water-based mud is the most frequently used. The drilling fluid used for a particular job is selected to avoid formation damage and to limit corrosion. Sludge, I've seen this one. You may want to stick to this one. Like what is LSAs, right? Sludge with low specific activities. Sludge is composed of dissolved solids which precipitate from produce water as its temperature and pressure change. Sludge generally consists of oily, loose materials, often containing silica compounds, and may also contain a large amount of barium. Dried sludge with a low oil content looks and feels similar to oil, and you will get this in your base of your tank. You can get this in the base of a pit too, like an abandoned oil pit, right? You can get it. You can get sludge there, right? Sludge contains radium. Although the concentration of radiation is lower in sludges than in scale, sludges are more soluble and therefore more readily released to the environment. As a result, they pose a greater risk of exposure. The concentration of lead is usually relatively low in sludge, but contains radium, right? Sludge is often found in shale shakers, separators, crude oil tanks, and well heads. Um, so maybe we could look at this one and we say, oh, there's one more, the inert gases. Let's read inert gases, just 2 slides, and then we know this would have been finished, right? So hazards of inert gases, below 11% oxygen is a risk of death due to asphyxia unless a person is resuscitated immediately. In general, oxygen deficiency can lead to a loss of mental alertness, distortion of judgment, brain damage. Asphyxiation, the effects on the body of inadequate oxygen, usually resulting in a loss of consciousness and or death. This is also known as suffocation or anoxia. It is absolutely essential to understand that with inert gases such as nitrogen, argon, helium, etc., asphyxia is insidious. There's no warning sign. It is to be noted that the use of inert cryogenic liquids such as nitrogen or helium is accompanied by two primary hazards. The fuel, or the liquids, right, are very cold, minus in the minus ranges, close to minus 200 degrees Celsius for nitrogen, and minus 269 degrees Celsius for helium, and can cause serious cold burns on contact with the skin, right? So this question here, following preparation of a vessel for maintenance within an oil and gas installation, a low specific activity LSA radioactive sludge was encountered. So this is a good question, right? This is typically for 8 marks. Identify 4 hazards associated with the sludge, right? So if it remembered, anybody want to say it? Outline 4 control measures to reduce the risk to workers exposed to the sludge. Remember that's where it's found and maybe how you can control it, right? And identify 2 pieces of workplace equipment where the sludge may be found. And all of that was actually in the notes itself. Anybody could remember from what we mentioned here, from what was kind of discussed, what is 2 hazards associated with sludge?
It contains uranium,
All right.
thorium.
Barium and radium.
Okay, good. And that's a radioactive source. What about anything come out anybody? Well, of course, remember you're not really studying them, but I suppose when you go to study, you'll kind of get it them because this was a past paper, right? Or you can go back to now because remember
Again,
we're not studying. Say it
um,
again.
contain silica compounds. So if you
Okay.
inhale that, it could cause an infection to your health, to
Okay.
your lungs.
Yeah. Yeah. So a good idea to understand I told you to do a question, but you could like once the C's are passive, but like you could go and do it and do it for yourself, right? So you see, so Stephen mentioned silica, looks and feels similar to soil, contains radium, right? I still say this will have a certain amount of hydrogen sulfide in it. Um, you just have to remember where I say it's found, but then that may not be everybody's experience. It's actually found like at the base of your tank. If a tank is left, like an oil tank, like they would have drained the tank. Like if you clean your tank or you clean, I guess, whatever you clean at home, like a fish tank, there's always that kind of bottom of it that looks like mud then, right? We used to call this BS. And I'm not too sure if the people in the oil field, if they still call it BS, right? But it's called it BS, but it's sludge, right? And I think like if you have to clean that, it depends on how hard it is. If it stays and it's hard, you literally have to go in there with a shovel and shovel it out of the tank, right? So you can think about if that's oil based because it comes from the oil wells, like the sediments that remain after oil has been pumped out of a tank. Then remember, oil floats on water, right? So like if you put water in a glass and you put some dirt in it and you leave it, you notice the dirt is settled to the bottom. So you can think of that as sludge then. So we know it's sort of a radiation source, but also it's hydrogen sulfide, right? It would have the hydrogen sulfide from the oil and stuff in it. So you could think of it as an asphyxiant as well as 2 possible hazards, right?
Also
Control
very flammable. I
measures.
think it,
Go ahead.
say based on the book, it contains pyrophoric ion, making it very flammable.
Okay, good. So that's a good answer, right? Um, 4 controls. So you could take the question. I mean, I mean, we all have access to like the world of resources now, internet and whatever have you, right? So you can take it and do it because it is a past paper question, right? Um, and with past papers, you have to do them because they tend to repeat, right? So speaking of that, I don't have much time, but I could still share the past paper I have here. Um, Again, I mean, when I came in, I kind of opened it at random. I know I have sent you one. Really not too sure if this is the same one we were looking at on Sunday, right? But we try to incorporate them as much as we could into this session, right? We could just have a look at them. So this is March 2018. Let's have a kind of look and see how the question showed up for this one anyway, right? So I think this is the same question. I remember the first one was on electrostatic charge. That's Sunday class, right? Sunday has a bit of electricity on it. The next thing we're looking at is electricity then, right? Contents of an emergency plan. Um, we did this one on Sunday, I think. The root causes of the accident. give the meaning of the term inerted. So we saw that today. Outline possible processes in oil and gas industry where inerting is required. Outline the risk from inerting atmospheres during maintenance. That's not what we did today, right? So we skipped that one. The contractor, fire precautions. Okay, vapor density, vapor pressure. We looked at that on Sunday. Safe operating envelope. We didn't really do that as yet, but I suppose every paper is different, right? We could open another one and see, but we wouldn't open it today. We'd open another one on Sunday if there's anything, right? But you have one. So thank God for that. You have one here on this slide that shows you a passive question, right? Don't ignore it. Like I said, in the world of Google and whatever have you, there's no excuse for not getting these things. It's too easy to get, right? They just said they Google, what is the hazards of LSA, and like you can actually plan it then and write it and keep it in a book. If you want, send it for me. I'll have a look at it. You notice not too much of marks, two hazards here, two controls there. Sorry, two places where sludge can be found here, and then four control measures here, right? Some of you are okay, we'll kind of bring it to an end there. I'll have to manually take a rule because I left the rule at the office, right? I think the Matt only wasn't sure about having class today, but I thought it best to have it because I know it's on the schedule anyway, right? So I know it's just about 10 of you, and we all seem to be here, right? Because I'm seeing 12 of you, right? So as I call your name, you just say present and you could leave. We have Jessica.
Present.
Thanks very much. Do the rest of your evening. Yeah, Akash.
Present.
Thanks very much. We have Alim.
Yeah, present, sir.
Thanks, Alim. We have Alicia. Yeah.
Present,
We have
sir.
Alicia again. We have Alicia. Kayan.
Present, sir.
Thanks, Alicia. Christopher.
Present, sir.
Christopher Goben. Okay, good. Well, Devon is here. Again, thanks for all the suggestion. Devon. Chanel.
Present.
Okay, Raven.
Present.
Stephen. Yeah. Stephen. We have Fluentech. Who is Fluentech? Just give me the name.
Naveen.
Okay, that's Naveen. Okay, all right.
Yeah.
Naveen. Okay, good. All right. Did I leave with anybody? Rashad?
Yeah, yes, sir. Right here.
Okay, good. All right, folks, all the best for the evening. Let me stop the recording and that will be it. I'll see you all back on Sunday, right? For 1 o'clock.